Welcome back to Educator. Next we're going to talk about a class of reactions called elimination reactions. The first reaction we'll study is called an E2 reaction for an E2 mechanism, and the name of that reaction comes from the fact that it's an elimination reaction and it is bimolecular. It is a one-step mechanism, very similar to the SN2. So the other mechanism we saw that was a single step was also bimolecular, and that has the same 2 that the E2 is, the SN2 backside attack substitution reaction. And something that the E2 mechanism needs is a strong base. So what are things that we know of as strong bases? Things like hydroxide or alkoxide, maybe an N- would also be a very strong base. Okay, so pretty short list of species that we would describe as strong bases. Those are the kinds of reagents we'll need to do an E2 elimination. And here's an example of one. Let's react, we'll start with an alkyl halide, and we'll react it with sodium hydroxide. That's a nice strong base. And what do bases do? Bases go after protons. The proton we're going to attack is located right here. It's not on the same carbon as the leaving group. Remember, the halide is going to behave as a leaving group just like it did in a substitution reaction. And the hydrogen that gets attacked is not on the same carbon as the leaving group. It's the next carbon over. So we call this not the alpha position, but the beta. This is called a beta hydrogen. The hydroxide, or whatever strong base we're using, is going to come in, and in a single step, it's going to grab that proton, form a pi bond, and kick off the leaving group. So the product we're going to get will be an alkene. We're going to get an alkene product. We're going to be forming a carbon-carbon double bond as a result of an elimination. The other products that are being formed, if I use hydroxide, I'm also forming water, the conjugate acid of hydroxide, and of course I always lose my leaving group, so I also form bromide as well. So this is described as an elimination reaction because you have eliminated both the beta hydrogen and the leaving group. So we lost HBr, so sometimes this reaction is described as a dehydrohalogenation because you've lost the hydrogen and the halogen. What do you think an energy versus POR diagram would look like? Well, it would be a lot like our SN2 mechanism because that was also a single-step reaction. Our energy versus progress of reaction, we would start at some combined energies for our starting materials, the hydroxide, the alkyl halide. We're going to end at some final product energy. Okay, assuming it's a favorable reaction, that's going to be an exothermic reaction. And in order to get from the starting material to the product, as usual, for our one-step reaction, we're going to go through just a single transition state to go here. So really the energy diagram looks very similar to that for the SN2. And what does the transition state look like? The transition state has a lot of bonding changes taking place all in a single step. First of all, we're forming a new bond between the hydroxide and the hydrogen. So forming bonds we show as partial bonds in the transition state. We're also breaking this carbon-hydrogen bond. So breaking bonds we're going to draw as a partial bond in the transition state. Let me draw the rest of my carbon chain here. We are also forming a pi bond between these two carbons, so we'll show a partial double bond being formed between those two. And finally, our leaving group is leaving, so we're breaking the carbon-bromine bond, and we'll draw that as a partial bond as well. So 4 bonds involved in this mechanism being formed or broken. And how about any partial charges that we need to account for in our transition state? In our starting materials, our oxygen is negatively charged, but it's neutral in the product, so that charge is disappearing. We have a partial minus on the oxygen. And our bromine starts out neutral but ends up as bromide, so we have a negative charge developing on the bromide. So that's what our transition state looks like for the E2 elimination mechanism.